So I was saying, you need to notice that this equation that they gave us is in the general form. And the general form of the equation of a circle is x squared plus y squared plus 2hx plus 2ky plus c, and this is equal to 0. That's something you need to remember. So let me just put it here. This is known as the general form. In our previous class, we learned how to find the center when given the general form. We said we could use the equations. There are two ways. So the first one, you could use the equation h, value of h is equal to the coefficient. So let me just call e of x divided by 2. K is equal to the coefficient of y divided by 2. For people who weren't here, or anybody who needs to review it, the center, so say this is my circle, the center, I'll put it in red, it's in the middle here. We know when given this form, x squared plus y squared plus 2hx plus 2ky plus c is equal to 0, or when given this standard form, we should just in this corner right here, this is the standard form, plus y plus k squared is equal to r squared. We know when given these, the general form and the standard form, that the coordinates of the center is minus h and minus k. The coordinates of the center is minus h and minus k. Remember that. So back to this now. We know these formulas to find h and to find k. It's the coefficient of x divided by 2. K is the coefficient of y divided by 2. What is coefficient? Coefficient of x is any of the terms that comes before x. So in this case, let me just erase this. The coefficient of x, any terms that come before x. In this case, so like in this, for the general form, it will be 2h. But in our example, in the past paper question, coefficient of x is the number that comes before x. So in this case, hold on now. So in this case, it's minus 4. So what I do now, I just substitute it into my equation. So coefficient of x divided by 2, so that's minus 4 divided by 2, which is equal to minus 2. That's my value for h. For k now, is the coefficient of y divided by 2. Coefficient of y is anything that comes before y. So looking at our example, this would be 6, because 6 is the number that comes before y. So I just substitute the values. The coefficient of y, which is 6, put the 6 there, divided by 2 is 3. All right. Everybody good with that so far?
Yes, miss.
We did this in a previous class, so if you feel like you need to review it, just check Google Classroom. So I need some space, so right. Now we have h. Let me write it out. We have h. H is equal to minus 2. We know now that k is equal to 3. However, looking at this, we know that the coordinates of the center is minus h and minus k, not h and k, minus h, minus k. So if we want to find the center, which has the coordinates minus h and minus k, not h and k, minus h and minus k, we know that h is minus 2. So what does that mean? Minus h has to be equal to 2. Again, for my visual learners, let me just erase this. Right to top. So if h is equal to minus 2, therefore, to get minus h, I need to multiply this h by minus 1. So minus 1 times h. But what you do to one side, you need to do to the other side. So I also have to multiply this minus 2 by minus 1. So that's minus 2 times minus 1. Minus 1 times h, and that's minus h. And minus 2 times minus 1, we know that two negatives, negative and a negative, create positive. And then we know 2 times 1 is 2. And that's how we got minus h is equal to 2. Everybody good with that?
Yes, miss.
Okay, just making sure. So now we know that minus h is 2. If minus h is 2, can anybody tell me what minus k would be?
Minus 3.
Minus 3, good job. So now we know that our center is minus 3. I mean, 2 minus 3. All right, so that's one step finished. Hold on, somebody, I need to meet somebody mic. Mute. Okay, nice. So that's one step finished. If you think you need to review it, Google Classroom. That's the way to go. Okay. So now we know our center is 2 minus 3. Step 1, done. Next step, find the gradient of the radius. We know gradient m is equal to y2 minus y1 over x2 minus x1. And to find the gradient in this case, we need to use the center and we need to use the given point. Let me just write what the given point was. The given point was minus 6, 3. So you decide which you want as what, x2 and y2 and x1 and y1. Doesn't matter. Remember, it's interchangeable. I just want this. Hold on. I just want this to be x1 and y1, and I want this to be x2, and I want this to be y2. So I have to do now substitute the values. Y2 is 3, so I put 3 there, minus sign, y1, which is minus 3. Don't let this trap you. It's not 3 minus 3. It's 3 minus negative 3. So don't make the mistake of putting 3 minus 3. Next, x2 minus x1. x2 is minus 6, so I put my minus 6 there, minus, put the minus sign, x1. x1 is 2, so I put my 2 there. We know that a minus and a minus is a plus. So this becomes 3 plus 3 over minus 6 minus 2, that's minus 8. 3 times 3 is 6 over minus 8. But if it could be reduced, reduce it. Always reduce it if it could be reduced. And that's why my final answer for the gradient of the radius, I could divide both of them by 2. 2 into 6 is 3, so I put 3 there. 2 into minus 8 is minus 4. And this is the answer for the gradient of the radius. Everybody good with that?
Yes, miss.
All right. 3. Remember, if you don't understand anything here, even the smallest things like why 3 plus 3 is 6, we know. Okay, here's. All right, so that's step 2, finished. Check process. Third step, find the gradient of the tangent. We know that the tangent, so this is my radius, this blue line is my radius. Say the purple point is my given point, which in this case is minus 6.3. So let me just put it here, minus 6.3. And the tangent passes through that point. Let me use yellow. So this is my tangent here, this yellow line. We know that the tangent, which is the yellow line, so T, is perpendicular to the radius. Radius is R, the blue line. Because they're perpendicular, that means that they meet each other at right angles. And we know when we were learning straight line geometry, we know that perpendicular lines, so let me just write perpendicular lines. You need to remember this. Their gradients, the product of the gradients is -1. So say I wanted the gradient of the radius to be m1 times the gradient of the tangent would be m2. If they're perpendicular, which we know they are, their product, so m1 times m2 would be equal to -1. We know that m1, which is the gradient of the radius, is -3 4, -3/4. Multiplied by m2, this is what we're trying to find. M2 in this case is the gradient of the tangent, and we know whatever m2 is, when multiplied by -3/4, the answer would be -1. What we need to do now, we need to find m2. We need to find the gradient of the tangent. To do that, you have to divide both sides by -3/4, and I would end up with m2 is equal to 4/3. If anybody doesn't understand how I got 4/3, just let me know and I'll write it down. So you good with that? Yes, no. Anybody?
Yes.
Okay. Final step. If you don't understand something, please let me know. So we finished the third step, and now is the fourth and final step. Find the equation. We know the two methods. Y is equal to mx plus c. Second method, y minus y1 is equal to m brackets x minus x1. Last time we used the first one, so let me use the second. So you put back your y minus, remember, you see the point that you're using when finding the gradient of the tangent, we need to use the given point. Given point. We do not use the center. We use the given point. Always. If you use the center, you will get it wrong. Use the given point. So when you're in your exam, remember my voice telling you that. Okay. So y minus y1 in this case would be 3. So I put 3 here. Let me just write that. It's x1, this is y1. So it's y minus 3 is equal to m. We know that m, which is the gradient of the tangent, is 4/3. In brackets, you put back x, and then minus x1. We know x1 is -6, so that's -6. Don't let that trick you. Y minus 3 is equal to 4/3. x minus and a minus is a plus, so this becomes x plus 6. And all we have to do now is transpose. Transpose means just making something the subject of the formula. We're trying to make y the subject of the formula. Why, if you're wondering? Because we need it in the form y is equal to mx plus c. Right. So just continue and make y the subject of the formula. Before I do that though, can anybody tell me what they got for the equation? Anybody? Anybody got an answer for this one? It's okay if you didn't, because this is your first one by itself. So just let me know. Did you get an answer or not? Anybody? Okay, wait, hold on. Okay. So, all right, no problem. Micaiah, good job. That's right. In case anybody doesn't know what I'm talking about, just look in the chat, she wrote it in chat. So, hold on. There's no time for this yet. We need to make y the subject. So, okay. Y minus 3. We could expand these brackets. So 4 and 3 times x is 4 and 3x. And then 4 and 3 times 6, that's plus 8. And now this is my final step. So this is my answer here. Y would be equal to get y by itself, I need to add a 3 on both sides. So y minus 3 plus 3, the minus 3 and plus 3 would cancel, so I'll just remain with y. 4 on 3x plus 8 plus 3. 8 plus 3 is 11. And that's why I have here plus 11. And this would be my answer. Everybody good with that?
Yes.
All right. Okay, time for you to do this one by yourself. Well, you did. Anyways. For this other question, I want to go in straight. I wouldn't go through all these steps like that. Right? Okay. We're doing this one now. Let me just, oh, okay. All right, this one right here. So just know the paper and the number. No need to write all the question. And we already did this first part in a previous class. Can anybody tell me what they got for the answer for the equation of the tangent? Anybody? If you need more time, do let me know. But is anybody finished yet? Anybody? You don't have to talk. You could type in chat. And you can send me a direct message too. Okay, still working. Let me know when you finish. Anybody finish now? All right, so we'll continue now. So the first thing, find the center. But in this case, we don't need to calculate it. They already told us that the center is 2, 1. So we know that steps finished already. Because the center is 2, 1. Center. And now we want the gradients of the radians. We know that the formula for gradient, m, is equal to y2 minus y1 plus x2 minus x1. Let me start looking over here. This is a given point, this purple, and this in the blue is my center. We know that this is the gradient of the radius, and to find the gradient, we need to use these 2 points. I would put this as x2 and y2. I'll put this as x1 and y1. But remember, they're interchangeable. If you wanted, this could have been your x2 and y2, and this could have been your x1 and y1. x2 is 7 minus y1 is 1. So I put my 1 there. Divided by x2 is 10. 10 minus x1 is 2. 2. 7 minus 2 is 6. 10 minus 2 is 8. So we have 3 and 4 as the gradient of my radius. Everybody got that?
Yes, miss.
Okay. If anybody did not get that, let me know. Can anybody tell me what the gradient of the tangent would be?
-4/3.
Good job. -4/3. So we know that the gradient of R is 3 and 4. So this step done. Gradient of the tangent, we know that the tangent is perpendicular to the radius. If you look at this yellow line, which is the tangent, green line, which is the radius, they're at right angles, so they're perpendicular. What does that mean? That the product of their gradients would give me -1. M1 in this case would be the gradient of my radius, which is 3 and 4. Let me use white. 3 and 4. M2, gradient of my tangent, that's what we want to find, is equal to -1. And we solve, and when we find M2, we will get that it's equal to -4 and 3. So the person who told me that, good job. That's the answer. So I'm going to continue now, but if you don't understand that, let me know. Right. -4 and 3. Can anybody tell me, anybody who finished, can you tell me what you got for the equation? Anybody got what the equation was?
Miss, I'm not sure, but is it y equals -4/3x plus 61/3?
Hold on, let me just. Okay, what's your answer? Y is equal to?
-4/3x
Mm-hmm.
plus 61/3.
Yep, that's the answer. Good job. Anybody did not get that? Okay, let me just do it. So which method do you want to do? Y is equal to mx plus c or the other one? Just one person to answer me. Which one? Anybody? Somebody? 10 minutes left. Oh, wait.
Y minus y1 is equal to x minus x1 dot method.
Okay. And good job, Mikhail. Okay. So using the second one. Let me just write it over. You need to remember this. Is equal to mx minus x1. When finding, I will keep repeating it because I don't want you to forget. When finding the equation of the tangent, you never use the center. You always use the given point. Why? Because the center does not touch the tangent. So you cannot use that. If you use that, you will get it wrong. So x1 in this case, y1 in this case would be 7, because this is a given point. So 7 is equal to m. We said that's -4 and 3. And then in brackets here, I would put back my x minus x1, which would be my 10. And I just transpose. Transpose means just trying to make y the subject to get in the form y is equal to mx plus c. Y minus 7 would be equal to, I could expand these brackets. So that's -4 and 3, x -4 and 3 times -10 would equal to +40 on 3. That's why this is my final answer in green. I need to add 7 on both sides. So y -7 plus 7 would be 0. So that's why I just put y is equal to -4 on 3x and 40 on 3 plus 7 would give me 61 on 3. And that's why this is the correct answer. Everybody good with that?
Yes, miss.
Yes. Okay. All right, let's learn something new now. We will answer these questions just now. Normals. Okay, so this is my tangent, this red line. That's what we just learned about. Remember, the tangent touches the circle at one point. So, oh, cannot see that yellow. At one point. So this point right here. Tangent touches it at one point. Now we're learning about normal. The normal line. The normal to a circle is the line passing through the center of the circle and the given point. This is my center, this black dot right here. The given point is this blue one right here. And you could tell this green line, which is the normal, passes through the center and it passes through the given point. Everybody seeing that?
Yes, miss.
Okay. And what you need to remember again, the gradient of the radius is equal to the gradient of the normal. So unlike the tangent, which is perpendicular to the radius, the normal has the same gradient as the radius. Why? Let me show you. So my two little sketches. This is y, this is x, y. Actually, I don't even need to do all that. Okay, so this is one circle, just a little sketch to show you. Center. Say this purple point is my given point on the circle. This green line is my radius. This is radius. And what we just saw, what we just learned about, was the normal. And this is what it looked like. Center, still the red dot. Given point, still the purple dot. But now I'll put the normal in blue. So the normal doesn't necessarily have to be this long line going through here. It could just be like this. And this is my normal, this blue line. I'll put capital N. If you look at these two circles. Isn't the radius the same as the normal? Like on the same line?
Yes, miss.
Exactly. Oh, that looks like a smiley face. Anyways. And if you didn't know, gradient of a line is constant. So the gradient of R is the same as the gradient of N. And that's why we said the grad of the radius is equal to the gradient of the normal. Everybody good with that?
Yes, miss.
Okay, let me know if you're not good with that then. Right, let's keep. So now that we know that, the normal, this green line here, is perpendicular to the tangent. Just like the tangent is perpendicular to the radius, the normal is perpendicular to the tangent. Or I could say tangent perpendicular to normal. Same thing. But just remember, these lines are perpendicular. Just like the radius and the tangent, the normal and the tangent are perpendicular. What I mean by perpendicular, they meet each other at right angles. So you need to remember that. Always remember that. Eraser. The radius and the normal are perpendicular to the tangent. But I could also say the tangent is perpendicular to the radius or the normal. So always remember that. Some examples. Find the equation of the normal to the circle x squared plus y squared is equal to 5 at the point 1, 2. For anybody who didn't notice yet, this question is the same one that I had on the tangent. See? Hold on. There's my. find the equation of the tangent to the circle x squared plus y squared. Same question, but instead of finding the equation of the tangent, now we're trying to find the equation of the normal. You need to remember this as well. When you see x squared plus y squared is equal to r squared, when you see the circle in that form, the equation of the circle in that form, the center is 0, 0. 0, 0 means it's the origin. So always remember that. Same question, well, mostly, but now we're trying to find the equation of the normal instead of the equation of the tangent. So some of the steps are the same. First step, find the coordinates of the center. But we know since it's in this form, we see x squared plus y squared. We know that the center is automatically 0, 0. Second step is the same. Find the gradient of the radius using the given point and the center. That's the same from the previous example. Gradient, y2 minus y1 over x2 minus x1. This, let me just write it out for my visual learners. Okay, I need to end this and we need to rejoin. We have less than a minute. So rejoin.